We've seen this twice before. First, a cigar-shaped rock speeding too fast to be ours. Then, a comet releasing gas that shouldn't exist near our sun. Both came from beyond our solar system and vanished before we could understand them. But this time, we caught it early. Just days ago, a telescope in Chile spotted something strange racing through the sky. Bright, fast, and following no familiar orbit. Astronomers ran the numbers, and the result was clear. It's not from around here. Another interstellar visitor, the third ever confirmed. Unlike the last two, this one's still near, still fresh, and finally within our reach to study. So, what exactly is it? Where did it come from? And why are these mysterious travelers appearing more often now? The discovery happened quietly on July 1st, 2025. One of the Atlas survey telescopes in Chile noticed a faint moving blur. At first, it looked like a routine comet, a fuzzy patch with a small tail, nothing unusual. But when the orbit was calculated, everything changed. It wasn't looping around the sun, it was diving in from deep space and racing back out again. The trajectory was hyperbolic, the unmistakable sign of something alien to our system. More simulations, data checks, and image comparisons confirmed it. This object didn't belong to any known path or catalog. That's when they realized it wasn't just another comet, it was interstellar, only the third one ever confirmed. Yet strangely, it didn't make much noise. No dramatic headlines, no breaking news, just a quiet buzz among astronomers who knew what they'd found. You'd expect the third interstellar object to make global waves, but maybe people are getting used to cosmic visitors. Or maybe it's because this one hasn't done anything spectacular. No weird shape like Oumuamua, no massive coma like Borisov. Just a fast, silent traveler passing through our system, easy to overlook. These objects don't announce themselves. They don't flare up or explode across the sky. They slip in, drift for a few nights, and vanish. Unless someone happens to be watching the right patch of space at the perfect moment. We still don't know how long 3I/Atlas has been wandering through our solar system. It could have been inbound for months, maybe even years, unnoticed until an automated sky scan caught its motion. That's what makes this different. Not because the object is wild or dangerous, but because this time, we actually caught it in time. You'd think a comet from another star system would dominate every headline. Yet when 3I/Atlas appeared, the reaction was oddly mixed. Some called it a harmless, icy wanderer, others hinted it might be a threat, and many ignored it completely. That's what sparked curiosity. How could the same discovery divide people so sharply? I started digging deeper to see how the story was spreading across the media. Searching 3I/Atlas pulled up hundreds of headlines from around the world, each one telling a slightly different story. Some claimed it came from the galactic center, others said it was the size of Manhattan. A few stressed there was no threat to Earth, yet the tone shifted wildly between sources. It was fascinating. The same discovery, but described in completely different ways depending on who was writing about it and where. Some called it a harmless wanderer. Others painted it as a cosmic warning. The contrast showed how information can twist and fragment as it moves through the media. In some countries, 3I/Atlas made front-page headlines. In others, it was barely mentioned at all. The uneven coverage made the story even more mysterious. How could something so rare be treated so casually? What truly caught scientists' attention wasn't just the news, but the numbers. This object is moving at roughly 60 kilometers per second, about 216,000 kilometers per hour. To put that into perspective, Earth orbits the Sun at around 30 kilometers per second. That means this thing is flying through space at twice our planet's speed. At that velocity, 3I/Atlas isn't just passing by, it's slicing through the solar system like a cosmic bullet. Whatever sent it on this path, it's not something small or random. It's an interstellar traveler racing across our neighborhood, and for once, We have a chance to watch it before it disappears forever. It's not just fast, it's unstoppable. The sun's gravity can't hold something moving this quickly. It's like trying to catch a bullet with a butterfly net. It just flies right past. Even if we tried sending a spacecraft after it, we'd never catch up. At 60 kilometers per second, this isn't a simple chase. To reach it, a rocket would need impossible acceleration or a complex chain of gravity assists, like in old mission proposals such as Project RA for Oumuamua. But that takes years, and 3 I/Atlas is already speeding away. Its velocity reveals something crucial. Objects don't move that fast by chance. It was almost certainly ejected from another star system, maybe flung out by a massive planet's gravity or hurled during a violent formation event. Its hyperbolic path proves it wasn't drifting. It was thrown out with force. In a sense, 3 I/Atlas is cosmic debris, a fragment of another world, exiled into the dark and now gliding through our neighborhood without even slowing down. Yet, despite that speed, it's still bright enough for telescopes to study. For now, we have a narrow window before it vanishes forever. You'd think by now we'd easily recognize a space rock, but interstellar ones still surprise us. 3 I/Atlas looks like a comet, faint, hazy, surrounded by a thin cloud of dust and gas. Some early images even hint at a short tail. That's why astronomers first mistook it for just another long-period comet, not realizing it was something far more extraordinary. But not everyone is seeing the same thing. Some observatories report almost no tail, while others say the coma, that glowing gas cloud, is barely visible. It all depends on timing, equipment, and perspective. Still, if we assume it is a comet, that already makes it very different from Oumuamua. Remember, Oumuamua didn't act like any comet we've ever seen. No tail, no gas, just strange acceleration without a clear cause. It was either a bizarre rock or an unusually quiet comet, and we never solved the mystery. At least 3 I/Atlas is doing comet-like things, releasing gas as sunlight warms its frozen surface. But even that raises more questions. We don't actually know how big it is. It looks bright, but brightness in space can be misleading. A small, shiny object can appear as bright as something much larger and darker. If most of its glow is from the coma, then the solid core might be far smaller than it seems. Some estimates suggest a diameter of around 20 kilometers. That's the upper limit. It could easily be just a fraction of that. Then there's its chemistry. What's in that gas cloud? If scientists detect carbon monoxide or cyanide, it could resemble comets born in our own solar system. But if those chemicals are missing, that might mean 3 I/Atlas formed in a completely different environment. That's what makes it so confusing and exciting. On one hand, it behaves like an ordinary comet. On the other, it's not from here at all, making it alien by definition, no matter how familiar the tale appears. We're left in that strange in-between, part known, part unknown, a cosmic hybrid that defies simple labels. We don't get many chances to study something like this, so every image, every spectrum, every single data point matters. Once it swings past the sun, it's gone forever. Right now, 3 I/Atlas is moving inward, getting closer to the sun each day. But it's not plunging in. Its closest approach, or perihelion, is expected around October 29th to 30th, 2025, at about 1.4 astronomical units from the Sun. That's slightly closer than Mars, but still far from Earth. After that, it will loop around and disappear into deep space. No return trip, no second look. Here's the rough timeline. Through August and September, it will be visible to large amateur telescopes and observatories. That's the prime window for high-resolution imaging and spectroscopy. By late October, it'll slip behind the sun's glare, making observations nearly impossible for weeks. By December, it should reappear, outbound, cooling fast and fading quickly. After that, it's gone for good, drifting back into the cold darkness between stars. No follow-up mission, no way to chase it. The clock is ticking. That's why astronomers worldwide are already reserving telescope time and coordinating observations. The goal isn't just pretty photos. It's about dissecting its light, breaking it into spectra to reveal what this traveler is truly made of. Because once 3I/Atlas vanishes beyond the sun's reach, so do our answers. And the mystery that came racing through our solar system will return to the stars, leaving only the data we managed to capture in time. This is where real science happens. With Oumuamua, we didn't have time to collect good spectra. With Borisov, we did, and discovered it was surprisingly similar to comets from our own solar system. But 3I/Atlas could go either way. If it shows unusual molecules or unexpected activity, it might become our first true chemical sample from another planetary system. Even if it turns out to be just an ordinary comet, that's still huge. It would mean other star systems form and eject icy bodies just like we do. Proof that we're not unique. It makes our solar system feel more typical, more connected to the rest of the galaxy. That might sound dull, but scientifically, it's one of the most thrilling possibilities. So far, we've only confirmed 2 interstellar visitors before this one, and even with such a small sample, they couldn't be more different. That's what makes 3I/Atlas so valuable. Let's rewind. Oumuamua, the first, didn't act like anything anyone expected. It had no tail, no coma, just an elongated, tumbling body moving fast through space. It reflected sunlight oddly, and then began accelerating slightly with no visible gas release. Some scientists said it was a comet behaving strangely. Others thought it might be a fragment of something larger. A few even floated the idea of alien tech because its motion seemed so unnatural. Then came Borisov in 2019, the second interstellar object. This one looked exactly like a classic comet, with a long tail, a bright coma, and familiar gases like cyanide and water vapor. It behaved just as our solar system's comets do, giving us the first direct evidence that other planetary systems produce similar icy wanderers. Borisov was exciting, but it didn't rewrite any rules. If anything, it confirmed that other star systems form comets much like ours. 3I/Atlas seems to sit somewhere in between. It's active like Borisov, but only mildly. Its coma is faint, its tail short, and some telescopes barely detect either. That's already sparking debate. Is it a weak comet, a frozen relic, or something entirely new? What makes this one special is timing. It's the first interstellar object we've caught early enough to truly study while it's still inbound. For once, we're not reacting after it's gone. We're watching it arrive. We can track it before, during, and after its closest pass by the sun. Something we've never managed before. That timeline is crucial. Oumuamua was already leaving when discovered. Borisov gave us more time, but it was already heating up and shedding dust. With Atlas, we caught it cold, before the fireworks. This means scientists can watch its awakening, how sunlight triggers gas release, which chemicals appear first, and how its brightness changes with distance. That data could finally reveal how these travelers behave as they cross from deep space into our system. It's not just what Atlas is, but when we found it, and what we'll do with that narrow window of opportunity. That's the real difference this time. A few decades ago, we wouldn't have spotted any of them. They've always been passing by. We just didn't have the eyes to see them. Space is vast, and objects like 3I/Atlas don't announce themselves. They're tiny, fast, and faint, visible only for brief moments before fading behind the sun's glare or vanishing into the endless dark. Unless you're constantly scanning massive sections of the sky, you'll miss them. That's what's changed in recent years. We've gotten much better. Surveys like ATLAS, Pan-STARRS, and the Vera Rubin Observatory have completely transformed sky watching. These systems don't just snap photos, they scan fast, wide, and repeatedly, building a living time-lapse of the cosmos. Then, machine learning steps in. combing through millions of data points to spot movement, brightness shifts, or strange trajectories, anything that doesn't fit what's already known. When something odd appears, even just a faint dot moving slightly off course, it gets flagged. That's exactly how 3I/Atlas was found. So it's not that interstellar visitors are suddenly appearing more often, it's that we're finally skilled enough to notice them. Now that 3 have been confirmed, astronomers are rethinking how common they might actually be. Maybe these aren't rare at all. Maybe interstellar debris is constantly drifting through, like cosmic background noise, always there, just too faint to see until now. And if that's true, we're on the verge of finding many more. Once the Rubin Observatory becomes fully operational, it'll scan the entire southern sky in incredible detail, again and again, for 10 straight years. If anything interstellar passes through, it won't escape detection. This isn't the end of the story. It's the beginning of a whole new chapter. We're not just spotting random visitors anymore. We're building a catalog, a growing archive of alien travelers passing through our solar system. Some will be rocky, some icy, some glowing with activity, others completely silent. Each one will carry a new clue, a fragment of how other worlds form, evolve, and toss their leftovers into the galaxy like drifting cosmic junk mail. The first question everyone always asks: can we send something after it? Every time an interstellar object appears, the chase idea comes up. And with 3I/Atlas, the timing's better than ever. We actually spotted it early, while it's still inbound. In theory, that helps. In practice, it's still nearly impossible. To catch something moving at 60 kilometers per second, we'd need a spacecraft capable of absurd speeds. That means either launching years in advance or using a chain of gravity assists, slingshotting around planets to build momentum, like Voyager or New Horizons did. But even those legendary missions took years just to accelerate, and they still wouldn't be fast enough to intercept something like this. There was once a proposal called Project Lyra, designed to chase Oumuamua. The plan: launch a powerful rocket, swing close to the Sun for an enormous speed boost, and intercept decades later. Ambitious, but by the time it would have arrived, the object was already long gone. With 3I/Atlas, the same temptation is back. Early discussions are buzzing. Could we modify an existing mission? Keep a probe on standby, ready to launch at a moment's notice? But the challenge isn't only speed, it's time. By the time we realize an interstellar object is worth chasing, we're already too late. Building and testing a spacecraft takes years, while the detection window lasts only months. And unlike local comets, these visitors never return. It's a one-shot opportunity. Some scientists are now pushing for a rapid response interceptor, a lightweight automated probe that could be launched within months of a discovery, fast enough to catch the next visitor before it vanishes forever. The race to build one might just redefine how we explore interstellar objects in the future. It's a brilliant idea, and the technology isn't impossible. But we're not there yet. Funding, design, and logistics all take time. For now, reality keeps us grounded. We're observers, not participants. We watch from afar, collecting as much data as possible from ground and space telescopes. And that's where it ends. Chasing these visitors is still science fiction, but the fact that it's even being discussed marks a major shift. Just a few years ago, no one was planning to hunt interstellar objects. Now it's a serious topic. It's not about this one, it's about the next, because we now know they're out there, drifting through our solar system more often than we ever imagined. 3 confirmed interstellar objects in less than a decade. Before that, nothing. That alone shows the change isn't in space, it's in us. We've finally started watching carefully enough to see what was always there. The first, Oumuamua, slipped away before we could react. 1,000 questions, almost no answers. The second, Borisov, looked more familiar but brought new mysteries. And now with 3I/Atlas, we're ahead of the curve. That's not luck, that's progress. We're no longer waiting for surprises. We're preparing for them. The Vera Rubin Observatory and others will soon scan the sky more deeply and frequently than ever before, making discoveries like this routine. Interstellar objects won't be rare anymore. They'll become part of everyday astronomy, cataloged, tracked, and studied like any comet or asteroid. And that's where the real transformation happens. Once we find enough of these travelers, they'll stop being curiosities and start becoming data, a brand new category of objects we can study, compare, and learn from. Each one a message from another world, quietly crossing our sky. Things that don't belong here, yet pass through anyway. Some icy, some rocky, some bizarre, some ordinary. But each one, in its own way, pulls back the curtain on what the galaxy is really made of. This isn't science fiction anymore. It's not just something you read about every few years in a headline or textbook. Interstellar objects are real, and they're going to keep coming. We're not sending probes to other stars yet, and we haven't caught alien signals. But we are doing something just as powerful, learning to listen when the universe sends a visitor to our doorstep. Each one carries a story from another world, and we're finally paying attention. The next few years could completely reshape how we see our place in the cosmos. Because for the first time, we're not just dreaming about other worlds. They're coming to us. If you enjoyed this breakdown and want to stay updated on every new space discovery, make sure to like, subscribe, and share. Your support helps keep these cosmic deep dives coming. Thanks for watching, and as always, keep looking up.